DNA is constantly subjected to damage, not only from exposure to carcinogens, radiation, free radicals, and viruses, but also as an inevitable result of the process of DNA replication itself.
Errors introduced during replication are common, especially within highly repetitive regions such as microsatellites. Microsatellites consist of short 1 to 6 base pair DNA motifs that repeat over and over again, forming characteristic patterns specific to each lineage.
Replication of these microsatellite regions is error-prone, but the mismatch repair system rapidly detects and repairs short replication-related errors. Heterodimers of MSH2 and MSH6 or MSH3 from the mut-S complex, which detects mismatches and short insertions or deletions in the copied DNA.
Upon binding to the mismatched region, the mut-S complex undergoes an ATP-dependent conformational change that recruits the mutual repair complex.
The repair complex composed of MLH1 and PMS2 identifies the affected standard and introduces a nick upstream of the error. An exonuclease progressively removes nucleotides until reaching the nick, and then DNA polymerase resynthesizes the excises region.
Finally, DNA ligands joins the newly synthesized DNA with the adjacent bases. However, individuals with Lynch syndrome exhibit a deficiency in mismatch repair due to a germline mutation in MLH1, MSH2, MSH6, or PSM2.
A duration in epicam can also cause Lynch syndrome by silencing MSH2. Individuals with Lynch syndrome have only one functional copy of one of the MMR genes.
Loss of the remaining allele is associated with a greatly elevated risk of early onset of certain types of cancer, including colorectal cancer and endometrial cancer.
Constitutional mismatch repair deficiency is a rare condition in which germline mutations in both alleles of the same mismatch repair gene are inherited, greatly increasing the risk of cancer in childhood.
Lynch syndrome-associated colorectal cancer is more likely to develop in the ascending colon, and tumors tend to be mucinous and poorly differentiated, with rapid progression from polyp to carcinoma.
As Lynch syndrome is inherited as an autosomal dominant trait, first-degree relatives have a 50% chance of being affected. And mismatch repair deficiency allowed errors to accumulate within microsatellite regions, ultimately resulting in frame shift variants within tumor suppressor genes.
In sporadic cancers, MSI can also be caused by methylation of mismatch repair genes such as MLH1.
Patients are classified as MSI high when microsatellite testing detects instability in more than 30% of the markers examined. Mismatch repair deficiency can also be detected using immunohistochemistry to evaluate staining of MLH1, MSH2, MSH6, and PMS2 proteins.
Although the risk of cancer is elevated, MSI-high patients generate a broad range of immunogenic neoantigens, making tumors more visible to the immune system. Therefore, MSI-high patients tend to respond better to immunotherapy with immune checkpoint inhibitors such as pembrolizumab and nivolumab.
Unlike targeted therapies that are only effective when specific mutations are present, immune therapy marshals the immune system to recognize and attack MSI-high tumors.